Okay, test 2. Why did it do that? Testing, testing, testing. Wow. I wonder if that's a preview. Oh, okay, good. So I had to. YouTube changed everything. It used to be you could just go live from YouTube using like a Hangouts platform. Now you have to download a streaming software. And hi, Mark, Marcel, Gary, Drew. Hey guys, Simon. Um, so I just downloaded Streamlabs OBS. I used the old OBS way back when it was beta version. This looks a bit more powerful and a little bit more complicated, so I'm just trying to figure it all out. Anyway, I'm working. ¿Qué tal? Matt. Hey Matt, what's going on? My brother's in here. So the back is in rough shape. Gary, thanks for asking. Stupid picnic tables. So they're cool looking, but man, they're beefy. And I had some help here yesterday, and it was just me and him, and we tried to move both of them. We got one out the front door, and then that was it. I was done. So anyway, I wanted to go through and start working on the six-legged walking mechanism. If you guys will look at the screen there, you'll see down here I have a arm off of one of Nerf's a Nerf robot. So between what I've seen Jamie Martinez do with his walking mechanism and what the engineer did with this and some ideas of my own, I think I can design a pretty stout machine. The interesting thing that's really cool about this particular walking mechanism, I have it all torn into bits right now, is that no matter which direction the head turns, so it walks in a straight line, but if you turn the head, it walks whichever way the head is, the face of the head is turned. So the body doesn't ever turn. The legs just articulate differently, so it moves in the direction of the head, or wherever in this case, the Nerf gun is pointed. So this is a Nerf gun, and it sits on top of this robot and turns. So whichever way you turn the cannon, it walks that way. And it's a really interesting mechanism. It's not overly complex. It just works off of a dual tripod kind of theory, I guess, and a mechanism that moves up and down. So this kind of moves in an oscillation, and the mechanics of it contract a couple mechanisms that make the legs actually take an up step and a forward step, or an up step and a push step. So pretty straightforward. But I wanted to go ahead and I got this was like a $158 Nerf gun. And I bought it just to tear it apart to see how they did it. And they did some really interesting things with the gear. So using some stuff I learned from this and some stuff I learned from watching Jamie and his walking mechanism and some ideas of my own, I wanted to design I was thinking a fairly big one, 8 foot tall, maybe 10 foot long leg span. But after considering the fact that I really want to take this to the Klingspor event in October, I need to make it so it'll fit in double doors. So that's 80 inches tall and, I don't know, 72 inches wide. So I'm going to do that, and I figured I would jump on my second channel and share some of that designing with you. I am just going to use SketchUp for this. I don't need anything more than that. I know a lot of people are really up on 360, and I use 360 for some things, but 360 is a slow editing program. It takes a long time to accomplish things that happen in seconds here. So just for the speed purposes, and we don't need anything more accurate than the 64th, and this goes to a 64th. So we're going to hit SketchUp today, and we're going to talk you guys through the design a little bit. First of all, we're going to start by designing a leg. There's two different kinds of legs. There's a leg with an upper arm, and then there's a leg with a lower arm, and those arms connect in three different positions to a central rod. I'm going to change the design a little bit of the legs. I thought about doing more of like a up and down kind of thing, so it would look more, I don't know, more mean looking when it was all said and done. And then that would also give us a little bit more motion on the leg. So when I pull on this lever here, you see the leg moves in and out. That would give us a little bit more throw. So on a scale, I'm probably doing like, I don't know, this is a 6-inch leg, and if I end up going, just over 2 feet tall, will be just slightly more than a quarter scale. This will be a quarter scale, so we'll be going up that. And yeah, so that's what we're going to do. What I'm going to do with this is I'm going to make these legs pretty long. The feet claws right here. I'm going to reduce the length of the overall leg that protrudes out of the machine, and then I'm going to lengthen the distance between the pivot point here and the center, which gives us a mechanical advantage. So it's, if you think about it like sitting on a teeter-totter or a seesaw, the further we have the mechanical advantage that way, the less effort it takes to move this part up and down. And since we'll be powering this with a drill, we want to have as much mechanical advantage as possible. At this size, there's no way it'll carry my 350 pounds, but I think probably will be safe up to probably the 150, maybe even the 200-pound range. So we will be able to put people on this, and it will be able to walk with people. So that's kind of the hope for this whole thing. So that's what I'm going to start doing now, is design that leg, and then we'll switch from that to the other leg, and we'll see how far we get. I don't have a set time here. I'm just going to go until I get bored. All right. Rod, hey, how you doing, man? So, let me see here. All right, a lot of things aren't working right now. It's not telling me if there's a viewer count. It's not showing me. I lost the comment section. So I'm going to have to really play with this a little bit to see what is actually working and what isn't. So if you guys are still hearing me, would somebody throw up a hey, I'm here kind of thing? I may have just completely lost the feed. Dun, 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 dun. Yeah, it looks like the feed might be completely gone. Hey, Steve. Lawrence, Dan, Rod, everybody? Okay, weird. It's just not showing me a viewer count, so it just basically says nobody's in here right now. So that's, again, something I'll have to learn more about this software and how it works. So to give us a basic gist of things here, we're going to start with an overall radius, and I think the overall radius we're going to go with on this is going to be 36, which will put us at the 72-inch mark. That's going to be our outside threshold. We don't want to go any bigger than that. We want a body mass, probably half of that, so 3618. That gives us 36 inches wide. Let's go with 16. No, I want it bigger than that. So I'm going to go 16, 18, 18. Yep. Okay, now for this, the reason the body mass matters in this is because we're talking about there needs to be a chair up here for someone to sit in. There has to be a rotation. This whole upper section has to be able to pivot on the bottom section, and I need to be able to put a reduction system, 4 large gears, and basically a big actuator that moves back and forth in here. So I got to make sure I've got enough room for that, and that'll keep my legs a little bit shorter. So my pivot points on my legs will be, let's go 36. That gives me 6 inches. Let's go 28. So that gives me 28, which means the leg pivot will be about 10 inches from there and 17 inches. So that's 7, 10. The mechanical advantage on that is better than half. So dun, dun, dun. Torque on the drill, 15 to 1. We actually need a little less than that. So we're going to go out just a... No, we're going to come back in just a smidge. Let's go 26 inch. All I'm doing right now is just trying to figure out some basic ideas about the size of this. So if I make the legs that stick out from the body short and stubby, that means we're going to have that power we need to move forward. And if I make them short and stubby, that also means we get a lot of extra mechanical advantage from the throw. But it also means this thing takes little tiny baby steps, which I just want it to move forward. I don't care if it's fast. So. Dun, 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 dun. I'm number one. Okay. All right. As long as everything's looking okay over there, this is my first time doing it with this new software. I'm just going to keep going. If you guys run into any problems, just throw it up in the chat. If you have questions, throw them up there too. I'd be happy to try and answer them. So this is, I'm going to go ahead and just make this. I know it looks like a circle with a bunch of circles on it, which it is, but this gives me some basic measurements I can yank from when I'm designing, so I know where my part about roughly the size of the parts that I want to use are. So we're going to start by making a rectangle, and then we're going to lay out the side of the claw, or the part that let's go 16 by 26. Gonna come down from that 6 inches. 4. And 6. Right about there. So right now I'm just getting a good idea about where I want the position on most of the stuff to be. So it's just going to give me spots to give movement to the whole thing. Now this won't make a lot of sense here for a second or 3, but it'll start coming together quicker than you think. So these legs, these are actually going to be the legs, and one of the things I need to consider with the legs is I'm going to use 1/2 inch material for the legs. So I need it to be, there needs to be enough size to them that I won't have to worry about any fracturing or compression or any shearing going on, and it's just going to be one layer of 1/2 inch on both the front and the back, and then a skin on the outside edge of it. So I need to make sure that I give this enough, depth as far as that's actually kind of cool, this thing. Maybe we'll change the name from Pathfinder to Crab. So, I'm going to back that up a little bit. I don't need quite that much. So we'll go from, about right there. Yeah, I'm okay with that. And stop that there. So this is not fun and exciting yet, but it'll start making a whole lot of sense here real quick, I promise. So I'm going to have 2 pivot points. I'm going to have on this particular leg, I need a pivot point on the upper part of the leg. And we're going to come right here and just doesn't matter what size the hole is at this point. I'll make that, I'm just going to go 1 inch, so 0.5. And we'll do the same down here. In this case, I want to come quite a bit distance from there. Neener, neener, neener. So I'm going to come down, let's go 7 inches. Let's go further than that. I'm going to add another 2. That's 9. That'll give, if I have a 9 from there to there, that'll give me, I'm not sure, maybe 150 pounds of pressure per leg. And on 6 legs, we're talking, when I say 150 pounds of pressure, I mean pulling strength. And 3 legs will be pulling at one time. So 450 pounds of pulling pressure, which is way more than enough. But I like to design with some overkill. So at this point, it just becomes aesthetics. What do I want this to look like? These are my two mechanical fastening points, here and here. And I know I need to keep a bunch of strength in this upper section here, this upper circle. I can do a few things down here to lose some of the weight because it's not going to structurally make much of a difference. That's a little... Looks like an old guy's flabby butt. I need to change that. Too far. Maybe that's it. Yeah, there we go. That's much better. Smooth that out on the top. So what I can do is kind of get this where I like it. And I mean, obviously I can change this once I know most of my measurements. I can come back and change it pretty quickly and pretty easily. Okay, I'm digging that. So we're going to do an accent and make this thing kind of look like it's mean. Go there. Hi, JJ.
Hi.
What you doing?
I'm
You want to watch Bo on the Go?
No, I'm going to sit on the couch and watch you.
You can sit on the couch, but if you keep interrupting me, you're going to have to go back out, okay?
Okay.
Sorry, my son just walked in. He's supposed to be out playing with chickens. So I'm just doing a flat file at this point. Now I'm just going to give myself some lines to draw some. I'm going really easy on this, nothing fancy. And in about a second, all this will make sense. So I'm going to start at these center points, and I'm going to come out, give myself, let's go 2-inch radius. And I'm just going to randomly stick them on here. Oh, I'm just going to randomly kind of just stick them. JJ, what'd I say, buddy?
What?
No talking.
I'm sorry,
I know you're trying to tell me something, but that's part of the deal. First iterations are almost always, parts of them stick, but most of it doesn't. So we'll see how this plays out. So once I have just some ideas about how I want this to kind of the overall appearance goes, I can start pulling this out into actual dimensional parts. So I'll grab this section here. That didn't stick. Why not? Let's just duplicate it. So this will be the base. We'll get rid of that line. We need that to stay. We need these all gone. So one thing about SketchUp, it's a little funky, but if you know a few tricks, you can get away from like that one right there. You see how if you're watching the screen, you'll see how that circle didn't actually pick up the geometry like this side did. And this side, when you click on it, the whole thing gets fuzzy. It's because SketchUp thinks that that's not part of this geometry. So I have to basically just throw a line in there somewhere that tells SketchUp that, hey, yes, this is part of the geometry. Again, same situation as before. But if you run into that, if any of you use SketchUp and you run into that, just grab your line tool, go to one of the small lines on the circles and just draw a line there, and that brings it back into the, oops, that'll bring it back into the geometry. And it's a real simple fix, but it can be frustrating if you're not familiar with it. Like again, here we go again. Let's see here. Okay. All right, so now that's my side. I can extrude that 0.5, make that a component, create. You know what, I don't want to, actually that one worked. Weird. You grab that. Okay, sorry guys, I've been kind of ignoring the comment section here. Yeah, I'm using the audio software on this stream, and this headset only records in mono, so it's only recording on one side and one channel. Normally, I would put this into like Audacity and export it as a stereo from a mono channel, so you get the sound in both, but it's not working out. Thanks, D. I don't know about that, but we're having fun in the meantime. So if I wanted to make this like, and I'm not first of all, I want to make very clear that when I say I prefer SketchUp over Fusion 360. I'm not digging on Autodesk. They make some really great software, and it is super handy in a lot of situations. But for most things that I do, it's just faster to do here in SketchUp. So, all right. So what we have is the side of one leg. After all that, let's give this some color. I think we'll stick with the orange for now. Seems that's, stay true to neener. We're not really a good orange in here. All right, we'll resort to my second favorite color. Bang. And then we'll go a little bit darker on the inner leg. So if we do that, I was going to say we could leave the color in those circles, and like so we have some. Yeah, let's do that. Let's go ahead and get rid of those. Explode. So I went through all that for nothing. Hat figures. I'm going to leave this center open because I want, oops, crap, wrong. So I don't want to delete the circle, that circle, because I'm going to have the leg mechanic parts inside of here. So I want to be able to kind of visually see that through all the way through that when I'm doing that, when it's moving. So it just gives it some visual interest as it moves, kind of that kinetic sculpture thing. If you can see the internal parts, it's exciting. If we hide those, you won't see any of that stuff that's going on in there. And the other opportunity is that'll give you a place to stick your fingers and get them all caught too. So you got to be careful about that. All right. Yep, that'll work. So let's make these both a component and stand them up. Okay. I'm going to go a good solid 12 inches on these. So let's just see. That's 1, 11, 10. Flip along green. Oop. That didn't work so well. Flip along red. What is my problem? Why is that not? There's no way. Apparently that was it. Oh, because I grabbed it that way. Bonehead. Yeah. Okay. So, what next? Let's do this. Alright. That is one beefy leg. We probably have to narrow that out so it comes down like a teardrop kind of effect, but I'm not going to mess with that right now. I'm just trying to get a real basic idea about how I want this whole thing to kind of appear. About that size. Yep. Alright, so let's take all this stuff and turn this whole leg into one component so it's not... And then what do we say on these from pivot? From pivot to pivot we were looking for 10. Let's go 10 inches. No, let's go 12 inches. So whoops. 120 inches instead of 12. That's a little bit much. Let's give that a little height. Boink. So this will be the leg that sticks out of the robot. We'll have a central pivot point right here. Let me actually do this properly here. 1139.64 starts 4 3/4, 11 3/4, 5.375. Okay, and then we'll get real specific about the junctures here. So, bing. Yep. Okay. Ooh, wish there was a little more meat right there. Refresh chat. Okay. So this is the long, well, it's not super long, but it's the boring process of kind of just figuring out what I want everything to look like and how it's all going to mesh together. And it's just so, you know, I realize it probably doesn't, as a viewer, it probably doesn't seem like it's fast, but compared to a lot of things, this goes relatively quickly. So we're going to push that out to 0.5. Give that a setback of 0.5. Pull that out to extrude, wrong extrude. Where we're going to be at on this. So 9.5, go to 9 on that. Uh-oh. Lucy? Oop. What did I do? Should be paying attention to what I'm doing. Okay. Sorry, I should be talking more, guys. I'm not doing a very good job of doing this, but oh, that's what I missed. What, Lucy? All right, that's the basic gist of it. Let me go ahead and hang on. I'm sorry. Yes, Lucy?
Jada's in big trouble.
Nobody's in trouble.
Mom,
I'm Lucy. I'm live, honey.
she's in big trouble.
Okay.
Stop it, I'll pick her.
Um,
And then give us possible.
Sorry, up pure concentration. You know what I'm thinking, guys? I'm thinking I don't like this. Is what I'm thinking. I think I want to go. This looks a little too much toyish, and I'm just not. I'm not. You know, not feeling it. So. But this is the process that you go through when you're designing something. You start with an idea or a concept, and I normally would probably do a more paper sketching first before I got to this part. But hey, why not? This doesn't take too long. I mean, we've only been on here for I don't know, not that long. But it's like if I get this right here. 60 degrees, right? That's a circle. So we'll go 60 times 5. Whoa. That's not right. Let's see what the legs look like when they're all spread out. So that would be the basic layout of the legs right there. And then each one of these legs will articulate in well, I guess a lot more than two, but X, Y, Z, and different things of it. So there'll be a rod running through. If you look at me here for a second, there'll be a rod running through this hollow point, and that rod will be connected to the center pivot axis, and that pivot axis is basically going in something of not a circle, but more of an oval shape. So as it goes in the oval shape, it'll pull back and forth on the leg. It'll also up and down on the leg. So this thing will go up and down. And then if the leg is off to the side, that's the unique thing about this walking mechanism. If it's in line with the way the motor is accessing, it just goes back and forth and up and down. As it starts to pivot away from the central axis of the oscillation, it goes up and down and back and forth like this. So can you guys see that? Yeah, like that. So it does some really interesting things. That does not make for a very smooth walking experience. It's pretty, it's got that whole dramatic boom, boom, boom thing, which is I kind of think is pretty cool. So that's why I like this mechanism. So the next thing would be on these legs would be to create central pivots, like for the whole leg to pivot on this axis and on this. So the x-axis and we'll call this the z-axis or the y-axis. And then from there we would go to find our center point. We build the motor up from there. So we're basically building this robot from the outside in rather than the inside out, which is what you'd do in a lot of situations where you'd want to start with your drive mechanism and build it from there. But in this case, we need our legs and our actuations to tell us how big of a motion or an oscillation we need to drive all of this. So because I'm starting with the exterior parameters, like I needed to fit through a door that's 72 inches by 80 inches tall. So those are my parameters. So rather than starting with the oscillation and designing it out that way, I'm designing it from the opposite direction so I can optimize the oscillation. I can say, okay, this is how big the parts are. This is the type of movement I want from them. So to achieve that movement, I need the oscillation or the drive to have that oscillation of, however big it needs to be to get the most or the optimum movement out of each of the each of the extremities. So that's why we started from the inside out. But I think we're going to call that for today. I've got it's 5:30. It's dinner time. Kids are starting to get pretty restless, and I'm not quite sure where Danielle is, so I'm going to go get them fed. Nerf does know how to make a tank tread version of this gun. Maybe go in that direction. Yeah, that's a cool idea. Tank treads are fun, and you can definitely do it with wood. My shtick is I build wood robots and power them with drills. The problem with wood on tank tracks is, first of all, they wear out pretty quick, so you'd have to put rubber on them. The second problem is connectivity. Like, how do you connect them to each other? Because, if you drill a hole a 1/4 inch away from the side of a piece of wood, there's some pretty serious pressures being put on it. So you have to really consider how you're going to deal with tear out and that kind of stuff, and how you would connect all those treads together. Now, there's ways to do it, but it makes for very big, very heavy tank tracks. So, it's possible, and it would definitely be fun. But and the other side of that is, tank tracks look fairly simple. They basically just look like a big belt. But when you consider each component of that belt is, maybe 5 pieces of wood. So you have the tread, you have the parts that stand up for the connectivity of the linkage, and you have 2 links that connect it, and then you have the bracing for it. So if you have, let's just say you have a simple tank track that's only got 50 connectivities on it, well, 50 times 5, so you're already into 250 just wooden parts that have to be made. So it's really easy to overlook. Like, this looks pretty simple. If you look at this design right here, there's not a whole lot to this right now, but when you start breaking it down, there's 6 legs. Each leg has, 2 outer parts. It has the main beam here, it has the outer beam there. So, and that's on both sides, so that's 4 times 6. There's 24 parts. Right now, that's probably 6 sheets of plywood, at least, just for the sides of the legs. Now we start getting into the back structure of the legs, and then these other parts. So we're looking at right now fairly easily 150 different parts just for these legs right here. And that doesn't include all the guts that go in them. So when you're designing, that's one of the things you have to think about, especially from a cost standpoint, because right now I'm looking at these legs at this size, and I'm probably looking at somewhere in the neighborhood of, I don't know, $500 to make those, just from the material standpoint, let alone the time. Maybe a little less than that, maybe a little more than that, depends on how those change out. So it's one of those things that you really have to kind of consider when you're doing this stuff. It takes up a lot of time, and by the time this robot was said and done, we might have 300 or 400 parts, all together in it. And that's a lot of parts. And each part has to be made, sanded, finished, fitted, all that good stuff. So you want to play with that leg? Yeah. Okay. Anyway, guys, thank you very much for tuning in. I appreciate it. I'm going to try and get better at seeing how this works, maybe find some ways to do some music in the background and do some other things with the chat itself. So I will be doing some more stuff later on this channel here. I won't be doing it on my main channel, just to kind of walk through the design process so you guys can kind of see it from concept to fruition and the changes that I make and maybe some of the thought process behind it. So thanks, guys. We will see you all later. Gary, I will do that. I'll tell him you said hi.